Yes, good morning. Colleagues, good morning.
Joseph, good morning.
Yes, good morning, doctor.
I want to leave you with your class.
Yes, it's okay, doctor. Thanks for opening.
Okay.
So, colleagues, good morning. And since the class is recorded, then other people will get us on their way. But I would like to understand whether people outside there, you are able to listen. Deo, are you able to listen? Yes, Deo? David?
Loud and clear, boss. Good morning, Joseph.
Morning to you. Good. And I was saying, since the class is recorded, other people will catch up what they would have missed when they are coming late from the recorded video.
Okay.
I understand you were all able to load the shared script and nobody needs assistance over that. Were we able? And we said this is very easy. What you need to do is to either get it from WhatsApp, but I've also put it on the e-learning platform. After you downloading it, just come and click on the upload. Allocate the file, then it is going to be uploaded within your working environment. So for last week, we basically looked at introduction to programming, which we said is very important. We introduced variables, and we said Python is an easy language, in which case declaring variables is very easy. You just have to come and say name equals to Alice, and once you put it in double quotations, then Python is going to automatically treat it as a string. And once you come and say age equals to 25, then this is going to be an integer. So are other data types, the way we have it in column on line 5. And if we want to print, I can just come and say print name, comma, age. That means I'm picking two variables, but I would as well come and just say print name, then it would print only one variable, which is name. So I went ahead to look at lists, and we said lists, they are the building blocks for handling data in Python, and they are the building blocks for writing clean code and short lines, because they give us the power to store data within a program in an efficient way. So in this case, we said this is ordered in such a way that within the first block of the list, we get within the first block of the code, that's where the first item to be inserted is stored. It is followed by items within the second. So the banana is going to be stored in the second block, and chili is going to be stored in the third block. But as we number them, it numbers beginning from 0, as we can see. Then it continues. So that way we said the list is orderly, okay? And then we said the list is mutable. Mutable means you can change values within the list. This is something that I demonstrated on line 15. So we can come, so we have our list called fruits. So we have apple, banana, chili, and then you can begin by saying fruits, and we use the reserved word append. So dot append orange. So it is going to go and append orange at the end of the list. Okay, it is going to go and append orange at the end of the list after cherry. So if I continuously, let's say append, so the list is going to be appended. So the issue is the first come is going to be on bottom, and the newcomers, they are going to go on top. So that's what we have here. That is what is being demonstrated here. Once we print out that list, then we have items that are being printed down. And with the lists, it allows duplicates. You can duplicate the list, as we can see, that we can say fruits.append orange for the second time. This item is going to be accepted. So we can have orange. All those two items within the list are going to be accepted. So we can as well change an item in the list by just coming and indexing the list. Reference the line in which the list is. I think somebody in the comments, what are you saying? Then we can replace. So here I come and say fruits 0 that go into the list called fruits under index 0, change that item and make it item 0 is the first item in. So it is going to come and change it. And originally we had apple, then it is going to put apple juice. We can as well so those are the basics. So when you are dealing with lists, you can insert items into the list, you can append new values into the list, and you can change existing values. You can also erase a value from the list. Okay, so let's proceed. This is something that we did on day 2, and I'm replicating it now. So let's go to another data item. This is still a recap. And there is what we call a tuple. And with a tuple, they are immutable. Immutable means you cannot change it. And they go into the ordered list. Okay? So for example, I may have coordinates equals to 10. So the first item is 10, and the second item is 20. So the difference between a tuple and a list is 1. We use these brackets. We use these brackets, the open brackets, open lists. So whereas we use this kind of brackets to open a tuple, and by immutable means you cannot change. You cannot just come and change the value of the list, as we can see. So if you have our list here, can print the tuple here. But when we try to change the value here, the way we did it with the list, it will generate a syntax error. Let me hope that's clear. And then let's go to dictionary. So dictionary is another data structure, and with it, the values have key values. For example, when I'm entering a value name, I have to give it a key value. So you open it using this type of brackets. And whatever value that we get, we have to give it a key value. For example, name, I'm going to give it a key value name, and then John. Then age, 22. Grade, A. That's how we can proceed. If we need to add anything, I may come and add anything like date of birth, DOB, okay? Then it has to be in full columns. Then the value. It can be 12, 02, 20, 15. Okay? So this is for this particular student. So that's how you first index. After indexing, you give it a value. So I should also extend the second student. So there we go. So we can print the second student if we wish, student being stored in the dictionary. So if you want to change values within the list, so you are going to mention the name of the list. In this case, it is student, and then you reference the key value and the new value in. So in this case, we have age equals to 20 to 31, okay? Student, name, so the name of the dictionary is called student, and then we are changing the name from John to William. So we can as well change the grade. So student, which is the name of the dictionary, the grade, we are referring to this, we are changing it from A to C, and then we can print student. So we can see the name has changed, the age has changed, the grade has changed, and we did change the date of birth. Okay, so that's it. So, and then, as you can see with the dictionary, so we have different records. So if we look at, if this data was in Excel, the first row would be the student, then the second row is going to be student 2. That means once we combine these records, the rows in the first one, which is the data for the dictionary 1, then dictionary 2. So we can concatenate, we can bring these two dictionaries together to have what would be a student database. So we are combining student and student 2 just by using this syntax, okay? So you come and say student database, that is the name of the database, equals, you open those kind of brackets, then you close them. And after closing them, you key value the first dictionary, then you pass over values to it. So my first is going to be student 1, that is the key value. Then I'm going to come and assign it value belonging to the first dictionary, this. And also come and give a key value to student 2, okay? And then assign it the key values for the dictionary, which is student 2. And ultimately, we have a database of all our records within the student 1 and then within the student 2. So in a basic database. If we can refer this to an Excel sheet, then we have row 1, row 2 appearing this way. So in case we have another student, we shall follow the same sequence. We say name equals to the new student. Another student can be, it can be, say, James, age maybe 22, grade B+, date of birth, you give the date of birth. That is a new student. So we shall follow this sequence. Student 3 equals to name, you give the new name, age, the new age, grade, then you give it a new grade, and date of birth, you give the new student the date of birth. And if you want to concatenate or to add this new student into the database, you are going to come here and add this student. If you have a dictionary, then you are going to put the new student here, say student 3. Okay, that is the key value. Then you pass over value to it. And the logic, you can understand it. This can be student 3. And the logic, you can understand it. They are separated by commas. So let me name student 3 here. And we say the new student is James. James is age 25. And his grade is going to be C+. And the date of birth is maybe going to be 23. So we can run this. So we have this, run this, and ultimately we run this. So we have our new student has been added into the whole database. Basically, I understand anybody now you can proceed to add a 4th student, a 5th student into the dictionary. So do you have any questions before we proceed? And in case we want to update any of the dictionaries, we can come and say student.update, that my dictionary called student update student 2. Then here it is going to try to combine. It is going to combine the dictionary 1 together with the dictionary 2. So the update is going to append values for dictionary 1 into dictionary 2. This is one way through which you can now combine. Another way was this. The second way was this. And the third way is using the operator this. Okay? So you have your first dictionary. This is the first rows within the record. The second rows, okay? And you use this key symbol to get the first dictionary combined with the third dictionary. And when you print, you have the 2 dictionaries combined. So this was all about the list. Okay? This was about the list. I have already explained this. This was all about the list. This was all about appending a new value to a list. And still, this was all about change the value of the list. And it comes to this. And we have already gone through this. And lastly, the last data structure that is very important as far as dealing with data is concerned is the sets. So the set is going to be, to declare a set, you use this symbol. It's quite different from the dictionary, because with the dictionary and the set, we are using the same symbols. As we can see, this is a dictionary. It is using these open brackets, okay? But the difference here, the dictionary will assign a value, a key term, But when it gets to sets, we are not assigning any values within it. Okay, that is one difference between a set and a set and a dictionary. So with a set, you just give it values, and you don't have to key the values, and then the set will not allow duplicates. Okay, it will not allow duplicates. Okay, so as we can see, we have our set called nums that we have declared, and we are assigning it the values 1, 2, 3, 3, 2. So 3, 3 are duplicates, and once we try to print, this is what it is going to print: 1, 2, 3. Okay, and we can add elements into the set just by naming the set and using the keyword add. Okay, and then you mention the name. Okay, we can as well remove elements from nums, which is the name of the set. Remove 2, then 2 is going to be removed. Nums update, then it is going to have 5, 6. Okay, then it's going to have 5, 6 as part of my list. Are we together, colleagues? Any questions as far as data structures are concerned? I'm repeating this, I don't know, for the 4th time, because it's very important. It's what we are going to be using every now and then. It's what we are going to use to write scripts, clean scripts, one-line script that is going to be using a lot of stuff for us. Can I pose a question? Do you have people here with some knowledge of database management systems? Do you have people here with some knowledge of database management systems, so that we can look at a practical example where data structures were applied? Do you have people here that have used Microsoft Access? Colleagues, do you have people that have used Microsoft Access?
Yes, we always
You have?
use it as a topic.
Pardon?
No, yes, we always use it at school. It's
The
as
way
a
you use it.
subtopic in Microsoft Office.
Yes. So when you are dealing with database management systems, we have columns and we also have rows, okay? The columns, they describe the attributes of a database. So it is these data structures that they actually use. So I would pose a question. There is what we call the index key, and the properties of an index or a primary key within a database is values should not duplicate. Okay? So if you are the person designing that application, the Microsoft Access Database Management System, which dataset would you select for storing the primary keys? Have you heard that question? If it was you designing Microsoft Access and you want to store keys, primary keys, that should, for every record, that should not duplicate, which dataset would you select? Is my question clear? Which dataset would we select? Would we go for a list? Would we go for a tuple? Would we go for a set? Would we go for a dictionary? Which one would we select?
a list
Then we would select a list. Why? Give us a reason.
because we may need to change a few things, and with time that would help us, because since it's mutable.
So since it is mutable, our colleague is saying we need a list, but we are saying we don't want the values to duplicate. In this case, that is the key word. Attributes, values, elements should not duplicate. So that means we are going to select a data structure that would limit duplications at any cost. So which one would we select?
Set.
Which one would we select?
A set.
Select a set.
So you would select the set. Why the set? Why a set? Who can tell us the reason why a set?
It is mutable, and then it doesn't allow duplication.
So in this case, we don't like to allow duplications, then we need a set, okay? We need a set. Then there is also a scenario, I want to store data, but I want the first come, the first served. Elements will go on top of the other in an ordered way, but also mutable when I can change them at any point I want. So which data set should I go in? Which data set should I go for? I want to store data in a way that the first item should go in the first block, the second item should go in the third block, and the fourth item, and it proceeds. But after that, I have to make sure that the items are mutable. Mutable means I can change them at any point that I want. So which data set should I go in? Which data structure do I have to go for? Yes. Which data set do I have to go for? First in, the first person sits in the first block, second block, and I have a pile of things. But I can remove an item or change it at any point that I want. Who can try? Not trying. Who can try? Nobody? Who can try? Just unmute yourself and let me know. We share this. Which one? Is it a set? Is it a list? Is it a tuple? All I need a set. Let me bring back their characteristics. Let me bring back their characteristics. So the characteristics are there. They say the list is ordered immutable collection. The tuple is ordered and immutable. The set is an ordered collection of unique items. Okay. And then the set, yes. So which one should we select? The first item first in a mutable collection. But mutable means the values can be changed the way you want. But I'm interested in an ordered list. Which one should I go for?
A list.
So I'm going to go for a list because I want the list to be ordered, but I want to change the values at any time that I want. So one example that I used here that was used to design some device are flash disks. The flash disks, they really based on the lists. So that the first item, they are stored in the first block, but you can change items at any point that you want without tempering the structure of the data. Okay? Another thing, I want to store data, but this data has to be ordered, but in an immutable way. The data is ordered in a particular order. It can be in a sequential way, it can be cyclic, but I cannot change the values. So which data sets, which data structure do I have to go for? Which data structure do I have to go for? Which data structure do I have to go for? Is it a list? I'll go for a tuple. Reason being, and a typical example here, which typical example would we give? CDs, compact discs. They were designed following a tuple. So as you put data, it follows a given disk. But when you want to change the data, you cannot change it. Okay? So I'm hopeful that we have gone through all the type of lists we have gone through all the data types. Let's go back to our presentation. It is lab session. All right, so let's proceed. And we said we can make use of the if statement, and we use the if statement to take decisions, okay? So if I have my variable called h, I can always come and test it. Okay, I can always come and test it. I can always come and test it by saying if age is greater or equal to 18, then if it is true, if this is true, then it's going to print for me, you are an adult, else you are a minor. So let's change this to some other value, 15. I save, and then I run. So you see this is else, you are a minor, and we said this is how we use the if statement. And we went ahead to use the for loop, and we said the for loop is basically based on values that it is iterative. And here it is using the range 5. That means if we say for I in range, so that means we have our values ranging from 1 up to 5, then it is going to print I. So it is going to begin from 0, 1, 2, 3, 4, 5. So it is printing basing on the value of I. Okay? And we said other statements that we can use. We can use the while statement. And the while statement, it depends on if this condition is true, then continue executing. Okay? That while count is less than 3, okay, is less than 3, print high. And then count plus equals to 1. There is some script that I shared that has lesson 1. It really describes this concept. But what this one literally means is that count equals to, this is the same as when we say count equals to count plus 1. That means it is getting the previous value, it adds on the new values, then it continues iterating. But as well here we can say while count is within the range it's within the range 5. This one would still work if I run it. Okay, so we cannot use it because it is less. So we need to use specific values, and the range gives us a list of values. But here we can use something I want to demonstrate that is very important, assuming that you have nums, which is a list. And the list is something like 1, 2, 4, 5, 6, 7. So here I would as well say while, so I'm going to borrow the keyword that we previously used. While count is less than the list, because this one returns a numerical value, an integer, so it will execute. So while num, let me use 1 because I've already used that variable up. So while count is less than the number of items here, continue executing. So there we go. Then something I wanted to ask that is very important in programming. Who can tell us what will happen if I use a greater sign here? I keep the code the way it is, and then I use a greater sign. Who can think about it? What will happen in case I come and I use a greater sign there? I change that to a greater sign and it runs. Who can think about it? Who can think about it? What if we use the greater sign there, that way? What will happen? This is a common mistake, or it can be a bug that we can find in our programs. Have you ever heard about infinite in mathematics? Infinity. Remember the concept of infinity in mathematics? So in case we use the greater sign there, this code, because every time count, len, this variable is going to be greater than this. That means it is going to execute unlimited number of times, and it may lead to the crashing of your computer. Your computer may end up crashing, okay? Because it is writing into memory endlessly. Are we together? So as we take decisions when we are writing code, we need to think about the memory we are going to be inserting, where we are going to run our code, okay? And we avoid things that would cause problems to our computer. But in this case, if I try to run this, it is going to run up infinitely, okay, writing into memory until when it is overfilled, and it may lead to the crashing of my computer. Actually, this program will ultimately hang, and I have to restart the computer to clean up the memory. Let me hope that's clear. Okay, so that's it. So we also introduced ourselves to how can we reuse codes. And we said after understanding structures, then we need to understand functions, okay? And functions, they are the building blocks for writing clean codes. They are the building code blocks for reusing codes. And they are the building blocks for what we call object-oriented programming. And we said functions begin with this keyword. So I have to mention the name of the function. I mean, this keyword tells Python that whatever that precedes this after space is the name of the function, and what goes in the brackets are the variables that this function is going to take, and what goes on after are statements that this function is going to execute, and for every function, it should have a return value. In this case, this function is called greet. It takes the variable name, and the return value is a statement that picks the string hello and concatenate it. The plus sign in programming means concatenating. Concatenating means combining two strings together. So, and picking the variable that the function is passing. So we have the return is hello name. And when I come and say print greet, then I'm passing over this function. This function is calling my function greet, and it is passing it a value called Alice. So ultimately, I'm going to have hello Alice. So if I want to greet another person, I'll just say print greet, the name of the function, then I'm going to pass it a variable. Greet John, okay? Greet Annette, greet David, greet Dale, greet Joanne. So that's it. But sometimes when we are declaring functions, we give them the default parameters. But in this case, I have my function called greet, and then I give it the default value guest, okay? Say that when I come and say print hello, the return value is going to be this. So when I come and just call this function greet without passing any value to it, then it is going to pick the default, which is guest, and says hello guest. But at any instances where I call a function and I pass it a new parameters, then it is going to replace the default with the new value. So I have it as hello Alice. Okay? Still in object-oriented programming, there are what we call classes. You can read about them. But a class has what we call the main function, and this is something that appears after class. So the class takes a higher precedence of a function. So within a function, within a class, we have functions, as we can see. We have class, and it begins with the keyword class, and the name of this class is called car, okay? And then we start writing functions. Functions are the blocks that would define the main characteristics that would define this car, okay? For example, it is able to drive, it's able to reverse, okay? It has its characteristics like color, the number of wheels, okay? Those ones would be functions, okay? And then the first statement is the main function, and this is how it is declared. As we proceed, we shall be learning when do we use classes, when do we use functions to write clean codes. And our understanding of functions, class, and classes is very well. Why? Even if we have not written our own code, we are able to replicate, to reuse already written codes, what we are calling libraries, within our language, in this case, Python language. So when we come and say my car equals to car, so I come that my car is the car that I want to describe, and then car is the name of the class. Then I come and pass over parameters to it. For example, the first variable is bland. I pass it Toyota, and then it is red. Okay? So if I want to pass these attributes of this car, my car, into the function called drive, I'll come and say my car dot drive. Okay, and this function that is called drive, it takes in nothing. Then it is going to execute it. Okay, it is going to execute the first one, then it executes my function, and then interpret it that way. This is enough for our understanding. In our way of doing things, we may not be able to write scripts, but we shall be using this kind of programming, calling classes, implementing functions within that class. Let me hope that is clear. In case you have any questions, then you can raise them, and you can also read further about object-oriented programming. And then, please, if you have any questions, then you can raise up your hand. If you don't, then I'll assume everything is going on well. Another important aspect is file handling, because we shall be reading files, we shall be reading text files, we shall be reading Excel files, we shall be reading Word files, okay? And we shall be using this code without changing it, okay? We use this code and we use the keyword with open, and this can be the name of the file, okay? If the file is within my running environment, okay? For example, here, the assumption was this file contains within my environment. So if I go to Jupyter Notebook, so the folder where I'm working from is where I'm opening this file from, and the W is a keyword that says open this file and write into it, okay, as F. Then it is going to open this file and write hello Python, okay? And then we can as well read the difference from what I've just explained. Here we are using the keyword R, okay, that with open this file within the same environment or directory where my script is running from, go and read as F and open. Then we shall be able to open this file. So you can practice this by changing these words, writing into the file, and seeing what is going to be executed. So we also said that we are going to be using comparison operators, that if we are comparing 5 greater than 3, 5 equals. This is how we use it. And I said, I circulated a script that has lesson 1 that really explains in details how you would use the comparison operator. So you can open it, practice, practice, and practice. Okay? And then we have the logical operators. And with the logical operators, this is how we basically use them. This is how we can basically use the logical operators. For example, now, This is another way of declare. Programming, like mathematics, has many ways of doing things, and I cannot show you each and everything. So this is another way of declaring two variables, x and y, and passing them values true and false. And then this is how we would print. And is a reserved word, okay? So here it says x and y, that if I have x, which is true, and y, which is false, then it is going to return false. So if I have x, which is true, and y, all, and all means that if true, if one element is true, then it is going to return true. However much the other element would be not right. So not x, it is going to return false. X and x means true, true, then it's going to return true. And y means false, false answer, then the outcome is going to be false. So in the other way of writing scripts, we are going to be using more of this, okay? Using the keywords and, or, not, okay? And, or, and we shall be using it in their correct way, okay? And this is very important, that if the first instance is true and the second is true, then the outcome is true. And when we use all, even if the first one is true, even if we don't get the true on the second one, then we have to use, it is going to return true. Are we together? People, any questions? Are we together? Is it interesting? Say one word all to before. Can somebody say one word all to? So that I'm also energized to go to the practical bit. We are taking it more interesting. Annette, can you say any word all to? Is it interesting?
It's interesting.
Very interesting. Not so difficult, I think, from the first and the second way that we are looking at it. So should we proceed? Annette, should we proceed?
Let's proceed.
All right, so we have the weather forecasting programs. I came up with this program purposely for our practicing, and I'm going to go through it. It's a bit of an assignment that everybody has to attempt. And I basically looked at how can we use lists as data structures into our program. Okay, so the first list is called rainfall, and it is taking up those values. And the second one is relative humidity, and it is taking up those values. And the second one is temperature. Okay, so before running this script, you would use Darlene. You would use Darlene keyword to get the length of each list. Because once we use these lists and they have different elements, then the program will not successfully execute. Are we together? So you're going to use Darlene. You have learned how I've been using Darlene into my programs. So then we have the months, and it is running from January, February, March, April, May, June, July, August, September, October, November, up to December. Okay? And we have, so now I'm applying the for I in range. Okay? For I in range 12. That for I in range 12, the reason why I'm using 12 is I'm taking the number of months that have been given. But if I want it to be more robust, I would come here and say, for I in len, then I get the elements of the list. I put it here. So it is the same. But this is more robust, meaning once I don't have enough data up to December, I will just remove the month here and my code will be able to run efficiently very well. Okay? Then if I'm using the if statement, if relative humidity I is greater or equal to 80 and rainfall is greater or equal to 100 and temperature is greater or equal to 26. What this one means, the first iteration is going to be 0. Okay? For I in the range 0, that means my program is going to come and pick relative humidity at 0 is 80, rainfall at 0 is 60, temperature at 0 is 24.5. Okay? And it has to bring me true and true and true in order for it to bring my forecast as rainfall. If any of these is false, then it is going to proceed and execute the second one. Remember indentation, we looked at indentation. Indentation is very important here. Okay, so if else, then it is going to pick the value that the value within rainfall 0 is it less than 60 and relative humidity 0 is less than 78 and temperature 0 is greater or equal to 25.5. If that is the case, then my seasonal transition is a dry season. Else, if these two conditions are not met, then the program is going to bring transition period. And I'm able to print. We said once we put the if element here, then I come and have these full columns here that the string inside can fetch variable names. That's what it literally means. So I have my month in I, okay, which is January, and the temperature in I, in this case 0, 0, 0, 0, and then it is going to return my forecast. And the program is going to loop until when it reaches December, and by the time it reaches December, it has counted 12 elements. Any questions on that? And the method of programming that I use here is what we call procedural programming. Any question on that? Can somebody add the word all to before we proceed? Somebody add the word all to energize me to proceed. And this is the outcome. David, can you add the word all to?
Yeah, Joseph, I'm interested in this, but I was not on I've just come back. So it bumped on me. I've just come back. I was kind of, I need to review again on what you say.
So who was following to say a word in your own way? Who was following to say a word? Mr. Kato, have you been following? Mr. Mike. Mr. Mike, the floor is yours.
I wonder, well, see, dry in 12 months or in 3 months?
Pardon?
When you print dry or rain, does it mean in 12 months or in 3 months? Going to have a season in 3 months and for another season. So dry in how many months?
Do they have any? I'm not getting you. You are not clear.
I'm saying
Mm.
that when you say print, can you print either dry season or rainy season? But you are saying in 12 months. Now, specifically, which season are you printing in?
No. This is a simple program. Don't take it practical. This is just a simple program. Don't take it that you can use it in our operations. We cannot. But it is looking that it can look at these values, rainfall, relative humidity, and then it takes a decision, okay? And we just came up like, if it is greater than this, then it is a rain season. If it is less than this, then it is a dry season. And if it is not, then it is a transition period into another season. Don't take it serious. We cannot use it in our operation, so we cannot discuss that. But just use it to understand the application of the concepts that I've tried to explain up. Are we together? Are we together? Are we within the same context?
Joseph,
Yes, please.
good morning.
Morning to you.
Mine is like a simple query. In your submission, you said that if there is no data for any month, for instance, if it's November, you remove that month from the list. Doesn't it affect the forecast?
Yes, it will. As I said, as you deal with data, it is very important to use the lean to calculate the length of the list. Because once one value, for example, is missing here, check. Now I'm narrowing the value for this list. So if I try to run it, it will not accept. It is going to generate this error, the index error. So it is very important as you collect your data sets to make sure that the data length is the same. Are we together? That if I try to reduce it, then I have to do it concurrently for everything. That if I come here and reduce for December, then still I have to come and remove the temperature for December. In temperature, I also come and remove the temperature, the value for relative humidity. And then I also remove the value for rainfall. So now this length for months is the same as for temperature, is the same as for relative humidity, is the same as for rainfall. Are we together?
Joseph, I think also you can comment it. If you comment it and then you reduce, could it work?
If
Then
I comment what?
If you comment the value, then removing them.
This value? Yeah,
No,
if
as
I
in
can
if you
comment
one, if you want a period, let's say maybe you want mom, or you want from January to May, and you comment the rest, and then run these other ones you have.
True. What it means. That's what it means. That you have your data, you have labeled it, and you don't want it to execute, then you are going to comment it. Because you know the kind of period that you are interested in. My purpose here was really to demonstrate that that the data has to be of the same length, the same number of elements. Are we together? This is procedure in nature. Let's proceed to, this is the same program. This is procedure, and this is object-oriented. And with object-oriented, I have my function called DEF. And once I write it, Python will understand I want to write a function. And after space, I have to give it a name, forecast season. And my function is going to take the first variable as months, the second variable as temperature, the third variable as relative humidity, then the next variable as rainfall. Okay? And this is the same. Within my function, okay, I get these statements within the procedure. Then I paste them here. I'm doing the same thing. So now, for me to use my functions, I'll just come and say that if I have this, rainfall as this, relative humidity as this, temperature as this, and months as this, then I'll just pass these parameters by getting the season, the weather, the forecast season, that is the name of the function. I just pass it the whole list of values, the whole temperature of values, the whole relative humidity of values, the whole rainfall of values, and then I execute. It is going to execute. This is ideally important, assuming now I have different data sets, okay? This can be for a particular region, say central. Another one is for northern Uganda, another one is central Uganda. So I can reuse this code just by mentioning the name of the function and passing over values to it. Is that clear? Michael, is that clear? So in this case,
Yes, it's clear now.
I'm reusing the code. Instead of me rewriting this again and again, I'll just come and reuse, okay? And to make my code robust, assuming I have more data sets, I can just come to this function, and I can add location as another variable, okay? And whatever that you add here, you have to also update your function, because once you don't do it, then this one will not execute, okay? That means I can mention if my data is well labeled, like it has the location, it has the latitude, longitude, or it has location like Entebbe, Kampala, Gulu, then I'll just come here and mention Entebbe, the months, the temperatures for Entebbe, relative humidity for Entebbe, the rainfall for Entebbe, then I'm able to get my output. So if I have Gulu, I'll just come and say, this is Gulu, the months for Gulu, the temperature for Gulu, relative humidity for Gulu, the rainfall for Gulu, and then it executes. And much sometimes when we are coding, this one can be giving me results, but when actually I don't know how the function looks. But when I read it, I get to understand a function exists somewhere, okay? And once I look for it, I'm able to make changes on it. For example, if I want to extend it by adding in more variables, okay? If I want to extend it further by using the for statement by extending from the months to a longer length, like 5 months, just by extending the length, okay? And this one extends the execution period.
Maybe to a season.
All to season.
Joseph, if you want to do maybe to a season, yeah.
I would extend this, okay? I would extend this if I have my data labeled, then I would extend this to a length, that is equivalent to a season. A season is always 30 days, isn't it? So I would just extend this and say
It's 3 months.
3 months.
3 to
that
4
is
months.
3 to 4 months, eh? And how many days are those? That's 120 or 160, sort of. It's 90 or 120. So whatever that you want, depending on which kind of analysis that you wish to do. Are we together? So when we look at robust things and we can understand these basic things, then it's going to be easier for us to break down a code that is a bit complex because we understand the basics. Are we together? And then making the code more robust, that's what I wrote, I may have my data sets and I want the way we put it, because I have my data set that is indexed. So I may begin from a particular index up to a particular index. I may have record my data set like January, that dry season begins from 0 up to 120. Then I'm going to say, I'm going to initiate my program by saying, let's start from 0 and end on 120. So there I'm getting the dry season. Then if I need mama, then it has to be maybe from March, April, May. Then that is going to be data that is indexed, maybe from 120 to something like 300. So you are able really to get the kind of things that you want. So you're able to get the relative humidity, the rainfall, the temperature, and then this is procedure, okay? Then we can just have this within your function and check whether it is doing the same. Also, I tried it also, here we are using the for statement, but we can as well use the while statement. That I equals to start, that the -1 means I want to index values from 0. Because if I don't do it, then the program is going to start from 1, yet the lists they are indexed with 0. So I equals to start -1, in this case, I'm initiating a function I. What is very important in functions here, that anything that is not part of your variables app, once you try to use it inside your block of code, then you have to initiate it with a value. Else, your code will not run successfully. Okay, so we have this, I equals to start. Start is a variable that is initiated, that is declared within my parameter functions, and end is also a variable. That is why I'm able to use it here. But I is not a variable here. That is why I'm initiating it here. I'm declaring it here to my function. That while I is less than end, this is similar to something that I did up, that while count was less than some value that is here, now end is going to be 50. If relative humidity, this is the same. And ultimately, we have this. Okay? And then here, I was trying to do what we call instantiation of our functions. Please, people, don't confuse this. This one just runs random values for the list. I just kept it here for you to learn that instead of typing here, we would just initiate this list with values, okay? And here it is using the for loop to start values up to 51. So just don't confuse this. Just test it, run it, break it down so that you are able to understand it. So we can use the for loop to loop through this, and we can as well use the while loop. Here, it's using the for loop, and here it's using the while loop. The functions that that I've just explained. This one is using the while loop. That's why has the word while, and the one that has subset is using the for loop. And you check whether you are able to get the same results. Any questions? Any questions if I give you mine? Because I have a long exercise for you. Any questions? All right. Now, the exercise that we are going to do, I shared on the e-learning platform, also in WhatsApp. I shared, let me try to get the PDF. I shared this Word document. So I shared that Word document. Are we all able to see the Word document? Are we able to see the Word document? Now, with this Word document, okay, Mike, we are able to see. What I want you to do is you are going to build temperature lists, relative humidity lists, rainfall lists, and these are the transitions you test with this. After that, you are going to fill in these gaps. So you run the code, okay? And then you fill in the forecast here. Just go. The codes, as we have checked, all codes are able to run efficiently well. The purpose of this exercise is you understanding which kind of code am I supposed to use. So if you have fastest with one variable, then with many variables, but you can also have this list as a whole, and you run it and check which section of the code is more robust. Okay? After that, I want you to go and attempt the quiz. And the quiz is also very easy. Let me share the screen for the quiz. That is the quiz. So the quiz, as you can see, it has what will be, it is one question. What will be the forecast of the weather model, given temperature, relative humidity, and rainfall values? So this is the temperature, this is the relative humidity, and this is the rainfall. And how do you get the answers? You run the model, and then you are able to generate the same answers. But if you do and fill up the table, all these values that we have in all of these values that we have within the quiz, they are contained within the table. Okay? All of these. But even if they are not, you can generate it depending on the quiz. The quiz has 10 questions. Run the code, get the answers, come and attempt. And as we said, the quiz, you can attempt as the maximum of 3 times. Let me try to log in. So you can come here, you go to my classes, and then when you click on this file, we are going to download the lab session files together with the table, unzip it, then come here and do the quiz. And I told you, the first attempt that you make, reset it so that the system is open for you. Attempt as the maximum of 3 quizzes. So that's it for now. I would use the remaining 5 minutes, answer your questions, and then we can go back to our day routines, if there is any. Do you have any questions? You can also let me know how the class is going, whether it is interesting, whether things are getting harder. But my interest is each day things becomes more easier, more friendly each day that we meet, such that after this period, we are going to meet for 1.5 months or 2 months. We must be, all of us will have to be able to write scripts that are robust, that are of standard, okay, that would add value to our services. Any questions? Any supplements? Any words of encouragement are welcome. I beg to submit. So friends, the floor is yours. You can come and say one word or two. So you don't have anything to say? So Israel is appreciating for the work well done. Thank you, Israel. I also wish to see you doing more quizzes. You only attempted once.
Joseph,
Yes, please.
I just have a simple concern. Like for
Yes.
us who are beginners, you've not illustrated. You illustrated once, you've not given us another, for example, an example. You ran, you got the output, then that for you the assumption you have is that
Who's this?
for us who are going to do the forecast, we shall. My name is Mabel Najuma.
Who? Najuma Mabel. Yes, because your computer
Mabel.
doesn't.
Yes.
Now, Mabel, when you log in into the e-learning platform, try to follow. We record these classes. As I said, we are building a block and we cannot go back. But each time that we meet, I actually make a recap. At least I go back like a quarter miles where we stopped from. Then I proceed. I would ask you, Mabel, to interact with your friends, to check the videos online on the e-learning platforms. These classes are there. I'm going to upload this class after here. So those people that have missed, the turn up is very low today. Let them use the recorded videos, okay? So that we are moving together. Because time is not our best ally. I was only given 1.5 months to have these classes conducted and have to respect that, have to work within those limits without affecting operations, because you people have to go back to your desks. Okay?
Well noted. I'll revisit the YouTube
Yeah,
videos
please
and then
go back. When you click on my courses, Let me try to show you. When you click on My Courses, then you click on View, those classes are here. The first class is here. The second class is here. Listen to the videos. The third class is here, how to install Anaconda. We had a class on indentation, it is there. Listen, and in case you need any elaboration, it's around. Then among us, there are people there are people where these concepts are not new to them. They are just refreshing. Consult them. There are some of your friends, this is their first time, but they have gone miles to understand concepts. Try to consult them because we are building a block and we cannot turn back. We shall break the building. And each class has, on each and every class, we build on the other. The second class is going to be more engaging, but with a more practical code. And then the other class is going to be more practical, sitting into our operations, writing real scripts. Are we together? So we cannot go back to the basics. The time is not there, but still they are going to be boring to people who have already picked the concepts. But the classes are there. This class is there. Just click on it. Okay, it's there. This is the class that we have. Madam Mabel, you see? The class is there. Okay? All right. So I understand we don't have more questions. Mike, were you able to install Anaconda? And now you are able to run the scripts?
No, it failed completely.
So colleagues, who can help Mike? Let us help each other. Who can help Mike? Benon is there. Benon has helped a number of people. So Mike, I would ask you help Mike. And I told you, in case you cannot use Anaconda, I shared a link where you can use Google Colab. Google Colab, you can run scripts online. Its only limitation is you have to be 24/7 on the internet. But if in the time being, you can use it. But when the codes get complex, it may somehow be challenging, but you can use it. Have you understood, Mike? You can use Google Colab. It has live Jupyter notebooks, and I remember I shared the link with you. Okay?
Yes, I will try using that. Okay, thank you.
And with Colab, you cannot install anything. There is also Jupyter Notebook online. There are a lot of resources, free resources that you can use. The most important thing, are you able to get something out of this class by the end of this lesson, by the end of these classes? Are you able to look at modeling, at scripting as one of the skills that you have, or you are still looking at them very nervous? This is the fear that I want that we are looking at the end of this training. That fear has to be outside us. Then some of us, we should also end up experts, being able to get data, run scripts, and we improve it, generating some of the products that you are getting from other models, given the data sets. Are we together? Yeah. So any other concern? If there isn't any other concern, I wish you a nice week. We meet on Thursday this week, next Thursday. Have a good day.
The same to you.
Bill?